so here's what you should have come up with for number 2. Oh goodness. Let's write your claim. The claim is always whatever's stated in the problem, and this claim is the variance. That's the symbol for variance. The variance of the life of the home theater sim is less than or equal to. There's the less than symbol. Put the bar underneath it to say or equal to 2.7. Okay? So there's the mathematical statement now that we're going to call the claim. It's either going to be the null hypothesis or the alternative hypothesis. How do we determine which one it is? It contains that bar. That bar is considered a statement of equality. So this is going to be labeled as the null hypothesis. Now, you can only be two things. You can be less than or equal to 2.7, or you can be, what's the opposite of less than or equal to? Well, I'm hoping that you're saying, well, if you're not smaller than and you're not the same size as, that's what that says. You're less than or you're the same size as 2.7. If you're neither one of those things, if you're not smaller than 2.7 and you're not exactly 2.7, then what are you? Well, you're bigger than 2.7. You're greater than 2.7. Okay, these two conditions right here are all the total possibilities. You're either going to be less than or equal to 2.7 or you're going to be greater than 2.7. These two are complements of each other, and they involve, you put them together, you've allowed for every possibility. Since this is a statement that does not contain equality, it's going to be the alternative hypothesis. And that's all you have to do. So let's try again. We've got a realtor here publicizes that the proportion, okay, the proportion, that symbol for proportion is going to be our P. Okay, our P. And then is more than. There's our math. Oh, I forgot to write the word claim. I'm sorry. Our claim. Our claim is that the proportion, which we use P to stand for proportion, is more than. Okay, the symbol that we use for is more than, is that symbol right there, is more than. And if you go over here and you look for more than, okay, you'll get it. It's this one right here. There's the symbol is more than. P is more than 0.24. There's the you change this right here to a decimal. That is equal to 0.24. So the proportion is more than 0.24. All right. So there's the claim written in a mathematical statement. We've taken the words and we've changed it. Now we've got to label this as, we've got to label what kind of hypothesis this is, the claim is. The claim does not contain equality. It does not contain equality, so it is the alternative hypothesis. Okay, what's the opposite of is more than? Well, if you're not bigger than 0.24, then that means you're either smaller than 2.4 or you're the same size. Okay, for those of you who are starting to wonder, yes, every time we use less than or greater than, one of them will have a bar underneath it, one of them will not. This one did not have a bar underneath it because it didn't say anything about equality, so that one will contain the equality. This one said is not equal, so this one contains equality. There will be equality on every single one of these. Since this is the alternative hypothesis because it did not contain equality, this one will contain equality, so it will be my null hypothesis. Okay. I forgot to highlight this is less than. Okay, the standard deviation. So first of all, let's start off by writing our claim. What is our claim? Our claim is that the standard deviation is less than 3. This is the symbol for standard deviation. This is the symbol for is less than, and then there's the 3. Which hypothesis is it? Well, does it contain equality? Is there a bar underneath it? No, it's not. It's this one right here. So it is going to be the alternative. Now we're going to write a statement that's the opposite of this one, the standard deviation. What's the opposite of being smaller than 3? Well, being bigger than 3. This one did not contain equality, so we have to put the equality down here with this one. And since this one contains equality, it's the null. Okay, last 2 examples. At least is at least. Okay, so what's my claim? The claim is the mean, there's mu, is at least. So you got to think about what they're saying here. The average number of people at the park. Is it going to be 2,000 if it's, or 20,000 if it's 20,000? Is it what they said? Is it true? At least 20,000 is yes. That means that 20,000 people, yes, their claim would be true. Would it be if they said if we only had 19,000? Would their claim have been right? No, 19,000 is not at least. So what about the other side of 20,000? What about 21,000? Is that at least 20,000? Yes. So when we say at least, we're saying 20,000 or 21 or 22 or 23. We're talking about anything bigger than 20. 20 is the starting point, and then anything bigger is okay. So anything bigger is okay, and it's okay for it to be 20,000. Okay? At least. If you're not sure, then come over here and see if you can find at least. There's at least. And at least for the null hypothesis, it's greater than, and for the alternative, it's less than. So we got to figure out which one this is. At least it could be 20,000, so that contained this number right here. So we have the bar. So since we have the bar, it contains the inequality, and that's going to be our null. What's the opposite of at least 20,000? The opposite of being bigger than or equal to 20,000 would be being smaller than 20,000. That's the opposite. The mean would be smaller. And if the mean is smaller, then that means it is the alternative because it does not contain equality, which is exactly what we found at least. And that's what it said it would be. The null would be greater than or equal to, and the alternative would be less than. All right, the last example, and then I'm going to stop this video before we move on. According to a recent survey, 52% of college students, that gives me a percentage right here. That means I'm dealing with a proportion. This is a proportion. And since it's a proportion, my claim is the proportion. Now, since it's telling me the proportion is 52. The proportion is 52%. These 2 words, proportion and the word is left off. And that's important because this word is right here is where I'm going to get my math symbol. And this word proportion is where I'm going to get my variable symbol. So those 2 words that are implied are the 2 very important words. So this one would be a hard statement to translate. According to a recent survey, the proportion is 52% of college students use their own income or savings to pay for college. So the word proportion is how I know to use P. The word is how I know that I'm going to be using an equal sign. Anytime it's is equal. Remember up here it said is not, was not equal to. So is equal. That's 52%. So the proportion is 52%. That's how you write it. It contains equality. Since it contains equality, that is which one contains equality? The null hypothesis contains equality. So that is the null hypothesis. And then what's the opposite of being 52? Not being 52%. So the opposite of the opposite of being 52% is not being 52%. That's the one without equality, so it's the alternative hypothesis. Okay. If you need some more practice, find these in the back of your textbook. I copied, I think, some of these from your textbook. If you can't find any, let me know and I will print some off for you and put it on there. But this is what you're going to be doing for the rest of chapter 7. This is going to be step number 1. You're going to have to write this, and then from that, you're going to have to go on. And the big picture here is we're going to decide whether or not we agree with the claim or not. We're either going to accept the claim or we're going to reject it. So that's what we're going to do. We're going to be figuring out, do we believe the claim? Can we believe the claim?